Alright, so now we're back with 3.2. So in 3.1 we learned how to graph the function f of x is equal to a times x squared. Okay, so this basically just meant we were graphing functions with a with a vertical stretch or a vertical shrink, and depending on whether a was positive or negative, there was also reflection. Okay, so this time we're going to learn how to graph, but this time we're adding a constant to the function. So what does that do? So that's the question we're going to answer today. How does the value c affect the graph of this right here? Okay, so basically it's the same thing as the absolute value functions. Remember when we had absolute value functions, we had absolute value of x plus or minus k, and this meant that we either shifted it up or shifted it down, right? So that's the same thing with absolute value functions, except we call the constant c. Okay, so when c is greater than 0 or c is positive, so plus c, then this is a vertical translation, shift or slide c units up. Okay, and then whenever c is less than 0, then it's going to be minus c, right? Then this is a vertical translation c units down of the graph. And the vertex, whenever you only have ax squared and c, like this right here, then the vertex of the graph is going to be 0, comma c, which means that this is x is going to be 0, this is the x. Excuse me, guys. So x is going to be 0, and then c right here is where we're on the y-axis. So this is going to be our vertex. And the axis of symmetry is always y is equal to 0 whenever we're in this type of form. So ax squared plus c. So let's just jump right into the practice problems here that we have. So graph the function, compare to the graph of f of x is equal to x squared. So let's see. So first of all, let's notice here that we don't have any vertical stretch or vertical shrink, and we're not reflected over the x-axis. So knowing that, I'm going to be graphing my function upwards. So I'm going to draw my x-axis towards the bottom here, and there's my y. Okay. So if I want to go ahead and do this right here, my table like I was doing last time in 3.1, I'll go ahead and do that. Okay, so here I'll put in f of x, and in this column I'll do g of x. Remember that these are outputs of two different functions. F of x is the parent function, and g of x is this function right here. And x column is the input column. So I've already determined that my function, that the vertex will be along the y-axis, right? Because x will be 0. So I know when x is 0, for the parent function, y will also be 0. Let me go ahead and color coordinate this a little bit better. So I'll do 0, and then I'll figure this out for inputs -1, 1, 2, 3, -2, -3. Okay. And then for f of x, we know that's going to be at 0, 0. And then here it's going to be 1 and 1, 4 and 4, 9 and 9. This is what we did last time, right? So those are the outputs whenever we input these values right here. So it's going to look something like this: 2, 3, 4 to 9. So my function should look something like that. Okay, now for g of x, let's do some inputs here. So let's input these values and see what we get out for g of x. So when we input 0, so g of 0, we get 0 squared plus 5, which is equal to 0 plus 5, which is 5. Okay, so when x is 0, g is 5. 1, 2, 3, 4, 5. So we should be like right there. Okay. Now, when x is 1 or negative 1, remember that this is going to be a symmetrical graph, so that means the outputs are always going to be the same on either side of the vertex. So this is the vertex right here. So when plug in 1 or negative 1, so let's do g of 1, we get this is equal to 1 squared plus 5. Well, that's going to be 1 plus 5, and that's going to be 6. Okay, so this is going to be 6, 6. Okay, and then when we plug in we plug in 2 into the function, so g of 2, we get 2 squared plus 5. That's going to be 4 plus 5. And that's going to be not 4 plus 5, sorry. 4 plus 5, which is equal to 9. So when x is 2, so 1, 2, it's going to be 9. And same with negative 2. Okay, so we know the function looks something like that. Also crossing at these points, right? Because that's 6. So whenever it's 4, it's going to be 9. And then whenever we plug in 3, we won't see it on this graph, but we plug in 3, so g of 3, we get 9, because that's 3 squared plus 5, and that's going to be 14. So 14 and 14, okay? So remember last time how we had vertical stretches or shrinks, and what we noticed from the difference between the parent function and those type of functions is that we were multiplying the outputs by the number that was out in front right here of the x squared. That's how we got the stretch. So notice here though that what's the difference between the outputs of f of x and the outputs of g of x? Well, you see here that g of x are 5 greater, not 5 times greater, but you're adding 5. 1 plus 5 is equal to 6, right? 4 plus 5 is equal to 9. 9 plus 5 is equal to 14. So whenever we're adding outputs to a function, we're adding to the outputs of f of x, which is the parent function. Okay, now and then knowing that for m of x, if this is x minus 3, let's just, instead of doing a bunch of tables of inputs and outputs, so I know here that this is positive and there's no stretch. Well, then I know that this is going to be facing upward. There's no reflection, right? Except there will be a shift. So I'm actually going to draw 1, 2, 3, 4. I'm going to draw my x-axis right here and my y-axis right there. Okay? So I know the parent function, which starts at 0, 0, and has the points 0, 1, or 1, negative 1, 1, and then 1, 2, 3, 4. Okay, so like that. So that's the parent function of f of x. And now we want to draw m of x. And here we know that we're subtracting 3 from every value of f of x. So that's what m of x is. Okay, so that means instead of at 0, 0, I'm going to go 1, 2, and 3. So it'll be down 3 units. And then instead of being at 1, 1, I'll be down 3 units. Instead of being at 1, 2, 3, 4, at 2, 4, I'm going to be down 3 units. 1, 2, 3, 4. Okay, so just like that. Sorry. Okay. And I know that it's symmetrical, so it'll be the same in the other direction right here. Okay, so I know my graph should look something similar to this right here. Just the same graph of the green graph, but now we're shifted down 3 units, right? Okay. So let's jump to, so number 3 has two things going on, right? So we have an a value and a c value here. So we're multiplying by negative 3 which means that we're going to have a reflection because of the negative and a stretch because of the 3. So that was from last time, but now we're also going to be shifted down 2 units. Okay, so let's go ahead and make our table. So here I'll put in my x values, or my input values, and then I'll do, I'm probably just going to skip f of x. I think at this point we actually know how to draw f of x. So I'll just do n of x right here. Okay, so let's just do that. And I know my input values will be 0. Well, first of all, let's find 0, -1, 1, -2, -3, 2, and 3. So if we plug 0 into n of x, we get n of 0 is equal to -3 times by 0 squared minus 2. Well, this will be 0, so we'll have -2. So our vertex is 0, -2. So if this is my y, 0, -2, 0 down to, and then reflection. So let's do that like right here. Actually, we'll draw this like up here. Okay, so 0, -2 will be right here. Okay, so if we plug 1 into the function, so n of 1, we get -3 times by 1 squared minus 2. So -3 times by 1 squared will be -3, and then minus 2, so that's going to be -5. So when it's 1, it's going to be -5. So 1, 2, 3, 4, 5, -5. And that's going to be on both. -1 and +1. Okay, now let's plug in 2. So n of 2, which is equal to -3 times by 2 squared minus 2. 2 squared is 4. 4 times -3 is going to be -12. Subtract 2, so it's going to be -14. So that's going to be way down there. So I know that my graph should look something like this, though. Probably a lot better, though. Okay, so it should look something like that. Okay, I'll let you guys try number 4 on your own. But let's jump down here and do some more exercises. So it says in exercises 5 through 8, it says find the zeros of the function. And what does it mean to have zeros? That means x-intercepts. So remember, that's what we learned in the last section. So x-intercepts. So like over here, like where the function crosses the x-axis. And this is the x-axis, right? Which is also the same as y is equal to 0. Okay? So whenever it says find the zeros, that's what you want to do, is that you want to make y equal to 0. So for number 5, let's say 0 is equal to -x squared plus 1. Okay? Now, you can either factor these if possible, but these ones are actually easier if you just solve for x. Okay? So there's really no need to factor these in order to find your x-intercepts. Instead, I'm just going to solve for x algebraically. So I want to make this positive. So I'm going to add x squared. So I'll get x squared is equal to +1. Now I know that I can undo exponents by radicals. So if I take the square root of this, or square root of both sides, that I'll have x is equal to the square root of 1. Now the square root, when you take the square root of a number, then the answer will be both a positive and negative. Okay? So the square root of 1 will be equal to positive and -1. So the zeros of the function, you can write them as x is equal to 1 and -1. So that's where we're going to cross the x-axis for this function right here. Okay, let's go to number 6. So it says y is equal to negative 4x squared plus 16. Well, let's say that we put 0 into the function. Okay. And for y, because we want to find the x-intercept, so this is equal to 4x squared plus 16. I'm going to add the 4x squared, so I get 4x squared is equal to 16. My goal is to get x by itself, so let's divide by 4. So I get x squared is equal to 16 over 4, which is 4. And to undo exponents, take the square root. So then x is equal to the square root of 4, which will be plus or minus 2. And that would be the answer. Okay, if you want to pause the video, try number 7 and 8 on your own. I'd recommend that you do that, but I'm going to continue. So I'm going to plug in 0 for my output variable. So it's equal to negative x squared plus 64. Add x squared to both sides. So I'll get x squared is equal to 64. Take the square root of both sides. So I get x is equal to square root of 64, which is plus or minus 8. For p of x, set it equal to 0. Negative 9x squared plus 1. So I'm going to add 9x squared. So I have 9x squared is equal to positive 1. Divide by 9. So I know x squared is equal to 1 over 9. Take the square root of both sides. So using properties of radicals, I know that x is equal to the square root of 1 over 9, which means x is equal to the square root of 1 over the square root of 9. So I can do that. So then I know x is equal to plus or minus 1 over 3. Okay. Now I'm going to jump to number 9 and 10. For these exercises, it says sketch a parabola with the given characteristics. So these characteristics say the parabola opens downward, so like that, and the vertex is 0, 5. So the vertex is either the highest or the lowest point of the parabola. So if this is open downward, we'll have the highest point right there. And we said that the highest point is at 0, 5. So if this is 0, 0 right here, and we go up 5 units, so 1, 2, 3, 4, 5, that's the highest point. And it says to sketch the parabola and that it opens downward. So we're sketching just some generic parabola that opens downward, and the vertex here is 0, 5. So go ahead and try number 10 on your own. You can pause the video for that, but I'm going to go ahead and do that right here. So it says the lowest point on the parabola is 0, 4. So if it's the lowest point, that means we're open upward. And the lowest point is the vertex, so the vertex is 0, 4. Okay, so if I were to draw my vertex, I'm going over 0 units and up 4, so 1, 2, 3, 4, like that. And it says that this is the lowest point, so we're open upward, like that. So as simple as that. Okay, so that should do it for this lesson. Really not too bad for either of these lessons. Again, a lot of the principles we've already used before, but with absolute value functions. So go ahead, finish this up, and then jump on the homework, which is in Big Ideas, and come to class if you have any questions. Thanks, guys.